welcome back. So what we're looking at today is 5.2, too big or not too big? That is the question. So let's go ahead and jump right in. So what we're looking at here is determining if the given values are solutions to a two-variable equation. So what you'll notice is every single one of these equations has two variables in it. They are not put into y equals mx plus b form like we're used to when we have our two variable equations. Instead, they are in standard form. But basically what we're going to do for this is we are going to plug each one of these points into the equation and see if it makes a true equation. If it does, then it's a solution. If it doesn't, then it's not a solution. So the one we're going to do together is number 3. So I'm going to make some space so I have writing room. So number 3, we have negative x plus 6y equals 10. We have our first point, negative 4, 1. So we have negative 4 plus 6 times 1 equals 10. Negative times negative 4 is going to give us a positive 4. Plus 6 times 1 is just 6 equals 10. 4 plus 6 is 10. So 10 equals 10. This is true. So A is a solution. All right, our next one, we have negative 22, negative 2. So we have negative, parentheses, negative 22 plus 6, times negative 2 equals 10. So always remember our ordered pairs are in the form x, y. So your x is always going to be the first value in the ordered pair. Y will be the second value in the ordered pair. So negative 22 is just 22 plus 6 times negative 2 is negative 12 equals 10. 22 plus negative 12 is going to give us 10. So 10 equals 10. This is also true. All right, our next one we have is 2, 2. So we have negative, parentheses, 2 plus 6, parentheses, 2 equals 10. Negative times 2 is negative 2 plus 6 times 2 is 12 equals 10. Negative 2 plus 12 is indeed 10. So this is another true one. Now, the last one, we have 10 zeros. That means we're going to have negative, parentheses, 10 plus 6 times 0 equals 10. Negative times 10 is negative 10 plus 6 times 0 is 0 equals 10. So we have negative 10 equals positive 10. Is this true? No. So D is not a solution. So only A, B, and C are. So on 1 and 2, it's the same idea. Now, you may not necessarily have 3 solutions for 1 and 2, but I will tell you, you are going to have more than one solution for both 1 and 2. So you do need to check all of them to make sure you know all the solutions, not just one of them. So solutions is your key word for this lesson, solutions. All right, the next part, find the value that will make each ordered pair be a solution to the given equation. So once again, we're going to look at number 6. So we're looking at the last one here. So we have 3x minus y equals 8. We're given 3 different ordered pairs, but we're only given one value in the ordered pair. We need to find the other. So for the first 2, we're given x, and we need to find y. For the last one, we're given y, and we need to find x. So for A, we're going to plug 2 in for x. So we have 6, because 3 times 2 is 6, minus y equals 8. We subtract the 6. We have negative y equals 8 minus 6 is 2. Divide by negative 1. We end up with a positive 2. Or sorry, a negative 2. Negative 2. Ignore that negative. Okay, for B, we're going to take and do 3 times 0 minus y equals 8. 3 times 0 is just 0, so that goes away. So we have negative y equals 8. We never want our variable to be negative, so we're going to divide by a -1. So y equals -8. So we have the ordered pair 0, -8. And the last one, we plug in a 0 for y. So we have 3x minus 0 equals 8. So this 0 is just gone. Doesn't matter. To get x by itself, we need to divide by 3. So 8/3 is our answer. X equals 8/3. So you can leave them as a fraction. You don't have to find the decimal. You can, though, if you so choose. All right. The next section, graphing linear inequalities. So graph the following inequalities on the coordinate plane. Name one point that is a solution to the inequality and one point that is not a solution. Show algebraically and graphically that your points are correct. So what you're going to do for these, we're looking at 9 and 10. So on 9, we have y is greater than -3/5 x plus 2. So same thing as when we are taking and dealing with linear equations. We start with the y-intercept. So we start at 2. Now our slope is a -3/5. That means we're going to go down 3. So 1, 2, 3. And to the right, 5. 1, 2, 3, 4, 5. Then we'll go up 3. 1, 2, 3. And over 1, 2, 3, 4, 5. So here is our line. Now, key thing when we're dealing with inequalities is whether we have a solid or dashed line. Now, we talked about this last semester when we have just greater than or equal to. It's a dashed line. So we talked about this more in terms of open circle and closed circle. So greater than or less than is dashed line. Greater than or equal to or less than or equal to, it's a solid line. So similar to our open closed, but slightly different. So this will be a dashed line. So you can just do it just like so. Now we need to figure out where this should be shaded. Is it everything below this line or everything above this line? So one way that I always use to take and determine shading is, so long as it's not going through the origin, I use the point 0, 0. So we'd have 0 is greater than or, not equal to, greater than -3/5 times 0 plus 2. So that cancels out. So we just have 0 is greater than 2. Is that true? No, which means any value below this line is also going to prove to be false. So our shading is everything above. So that's what we're looking at there. Now, remember on number 10, this one's a little weird. It's just y is greater than or equal to -6. So if we think about this in terms of just regular equation, y is greater than -6, it'd be what kind of line? Horizontal or vertical? Well, it's a y equals, so it's horizontal. So 1, 2, 3, 4, 5, 6. So here is -6, and it's just going to be a line that goes straight. Oops. Should be a line, solid line that goes right through there. Now, what we need to determine is which direction do we need to shade this, above or below? Well, if we pick -7, is -7 greater than or equal to -6? No. It's everything above. So that is what you're looking at there. So make sure you are very careful with your lines and whether or not they're solid or dashed. That's very crucial in this. All right, the last part, solving inequalities. So for part A, first we need to solve for x and then we need to graph it. So make sure you do both parts. So we have 10 minus 3x is less than 28. So we're going to solve this the same way we would if we were dealing with a plain old linear equation instead of an inequality. So we have 10 minus 3x is less than 28. First thing we want to do is subtract the 10 because our goal is to get x by itself. But first we have to take care of that addition and subtraction. So we get rid of the 10. Now we have negative 3x is less than 28 minus 10 is 18. Now we are dividing by negative 3. Hopefully you recall that when we divide by a negative when we're dealing with inequalities, it flips around the inequality symbol. So now we have x is greater than 18 divided by negative 3 is negative 6. So x is greater than negative 6 is our solution. So we're going to come down here. Here's our negative 6. This would be negative 5. Here's 0. There's 1. What kind of circle are we going to have? Open or closed? We're going to have an open circle, and it's greater than, so it goes to the right. So select an x value from your graph of the solution of the inequality. Replace the x in the original inequality with your chosen value. Does the inequality hold true? So if we pick negative 5, we would have, so let's look at 0. Make it a little more drastic. X equals 0. So that means we have 10 minus 3 times 0 is less than 28. This goes away, so we have 10 is less than 28. Is this true? Yes, this is true. Now, we're going to select an x value that's outside of the solution set on our graph. So that means something that's not to the right of negative 6. So let's do negative 10. So we have 10 minus 3 times 10 is less than 28. 3 times negative 10 is a positive 30. So we have 10 plus 30 is less than 28. This is 40. Is 40 less than 28? False. So we have shown that we did draw this the proper direction. So for number 12, it looks like a lot of work, but I promise you it's not. So first thing you're doing is you're just solving for y. Then you're going to rewrite the equation right here. And instead of having it be y is greater than or equal to or less than or equal to, it's just going to be an equal sign. So you're just changing the sign from what you had in A to an equal sign instead of an inequality. For C, you're graphing it. D, you name the y-intercept. E, you name the slope. So the parts that you would use to take and graph it, you're going to state those. Then you select a point that's above. You replace it. Is it true? Then you select a point below. So this is like where I plug in the 0, 0. You find out if it holds true, say whether or not it does, explain how you know where it should be shaded, and then decide whether or not it should be a solid or dotted line. So it's basically, this is showing the thought process for what we did on these right here. So you can use that to help you think back to what you did here. You're just answering all those questions, all of them wrote out, okay? All right, if you guys have any questions, feel free to ask. Have a wonderful